Hello, students. Shall we derive the equation for conduction through a slab? Come on, let us derive the equation. So, conduction through a thick slab. So, let us consider a slab of thickness x and area A. Consider T1 and T2 are the temperatures of extreme surfaces of slab expressed in degree Kelvin. So this is left side surface and this is the right side surface of the slab. So left side surface is maintained at temperature T1 and right side surface is at temperature T2. Now when heat is flowing through this slab, say Q is the heat flow rate through the slab and K is the thermal conductivity of this slab. So this is the simple line diagram where slab is there of thickness x and surface area A and it has got thermal conductivity K and heat is flowing in this direction. When heat flows in this direction, if you assume T1 is greater than T2, then heat flows from which side to which side? That is left to right. Left to right. So when heat is transferred through this slab, you will observe temperature decrease when it reaches to surface 2. If you take the slope, then dt by dx is the temperature gradient in this. So we are taking x is the thickness of the slab, A is the area of the slab perpendicular to the heat flow. Heat is flowing in this direction, perpendicular direction is this. This is the area we are taking. T1, T2 are the extreme surface temperatures. Q is the rate of heat flow. K is the thermal conductivity of the slab. So before deriving equation for this, we have to assume some of the things. So assumptions that are made in this are, we are assuming first one, steady state flow of heat. That means rate of flow is same throughout the slab. Then thermal conductivity does not vary with time. That means K remains same. So rate of change of heat, that is rate of heat flow is same, then thermal conductivity remains same, then heat flows takes place in only x direction. Only in this direction heat flow is taking place. That means no heat flow in y and z direction. Last assumption is extreme surfaces are isothermal, that is maintained at temperatures T1 and T2. Now as per Fourier's law of conduction, so as per Fourier's law of heat conduction, so rate of heat flow through the slab, through the slab is Q is equal to minus Ka dt by dx, that is temperature gradient. If we take dx this side and q this side, then dx is equal to, I am writing equation like this, Ka by Q into dt. So, to calculate the exact heat transfer through this slab between left side surface and the right side surface, so we are integrating from 1 to 2, that is from 1 to 2 we have to integrate this equation. So, integrating this, that is dx is equal to minus Ka by Q is the constant, cell dt, integration of dt. So, here if nothing is there means 1 is there, here also 1 is there. So, integration of 1 is, that is x, 1 dx is x, and integration of 1 dt is t. And you are integrating between the limits 1 and 2. Now, here, that is x, apply the limits equal to, that is minus Ka by Q, integration of 1 dt is t, that is limits 1 to 2. So, if you apply the limits, it will become x2 minus x1 is equal to minus Ka by Q, this is T2 minus T1. If it is flowing left to right, that is T1 is greater than T2, you can write this as minus Ka by Q. If you write this as T1 minus T2, then this negative sign goes. So, x2 minus x1, this is the x2, this is the x1, that is thickness you will get. So, x is the thickness. So, therefore, heat flow through the slab, that is Q is equal to Ka by x T1 minus T2, or you can write Q is equal to T1 minus T2 divided by x by Ka. So, here you will come across 3 terms. If you take this, then the ratio of Ka by x, already you know, this is thermal conductance of the slab. If you take this ratio, that is x by Ka, it is thermal resistance. That means ability of the slab or the material to resist the heat flow is called as thermal resistance. And if you write A left side, then you will get, that is Q by A. This Q by A ratio is called as, that is heat flux density. Or even we can call this as thermal loading of heating surface. Thermal loading of heating surface. So, this is the simple derivation of conduction through a thick slab. First, consider the slab of thickness x and a. Write down all these. Let x thickness, let a, that is area of the slab, perpendicular to heat flow, T1, T2 extreme temperatures of the surface, Q is the rate of heat flow and T is the time of flow. If you want to calculate the total heat flow in the, you can write Q by T is equal to Ka T1 minus T2 by X. If you want to calculate, that is total heat flow in the slab, just multiply this by P. This is the total amount of heat flow in the slab. So consider Fourier's law of heat conduction. Write the equation Q equal to minus Ka dt by dx. Then rearrange the term dx equal to minus Ka by Q dt. Integrate between the limits 1 to 2. Then you will get x 1 to 2. That is integration of 1 dx is x and integration of 1 dt is t. Apply the limits, you will get this equation. x2 minus x1 is x minus Ka by Q and T2 minus T1 you can write it as T1 minus T2. So this is the final equation for the heat flow through a thick slab. And while deriving this equation, you are assuming all these. Rate of heat flow remains same, thermal conductivity remains same, only heat flow takes place in x direction and extreme surfaces are maintained at constant temperatures. Thank you.